Disorders of sodium are actually disorders of water. Sodium is a marker of the tonicity of the blood. It has nothing to do with salt. So when you see an abnormal sodium, you should think abnormal free water. I'm going to get out in front of it now. Volume status is different than free water state. When you see an abnormal sodium, there may be a volume problem. And that must be something that you have to determine in addition to the free water problem. So let's talk about a little bit about the pathophysiology of water in the body, then go through a diagnostic approach of what you should do and how you work up hyponatremia. Then we'll talk about some of the maneuvers you can do to treat certain disease states, knowing that a lot of the diseases we're going to mention here are covered elsewhere. This is how I see the body in regards to tonicity and water. And it's just like general chemistry. You have the blood and you have the cells. And they are separated by a semi-permeable membrane. You've got some stuff floating in water on the blood side, and you've got some stuff floating in water on the cell side. When everything's in balance, there's an equal amount of stuff and an equal amount of water in both places. In the case of hyponatremia, that is too little stuff, what happens, you've got too little stuff in the blood and the cells are the same. Water is going to flow uphill from an area of less concentration to more, where there's more water to less. So in this case, water is going to flow into the cells. This causes swelling. And it does this in an attempt to balance out the tonicity. Swelling is bad. On the opposite side, hypernatremia, too much stuff. You have too much stuff, too little water in the blood. And again, water will flow, but this time out of the cells. This causes shrinkage. Again, in an attempt to balance out the water. Shrinkage is bad. Both lead to symptoms. And the severity of symptoms is going to be dependent on calculus, the dp/dt. That is the change in sodium over the change in time. So big sodium swings cause severe symptoms. But smaller sodium swings that happen very acutely can also cause a lot of symptoms. So what are the symptoms of sodium disorders? Well, for both hypo and hypernatremia, I want you to separate the disease states into three categories: mild, moderate, and severe. In the severe case, what you're going to get is coma and seizures. In the mild case, completely asymptomatic, you happen to get a sodium on a lab draw and it's abnormal. And moderate disease is going to be anywhere in between. But what you should generally look for are these non-specific vague symptoms like nausea, vomiting, confusion, or headache. But the symptoms are not specific. So if you check a sodium level and it's deranged and they don't feel it, they're asymptomatic. You check a sodium level and they're obtunded or seizing, it's severe. If you check a sodium and they have any other symptoms, consider them moderate. Hyponatremia is much more complicated than hyper. So let's talk about hypernatremia first. Hypernatremia means a free water deficit. And the best way to replace free water is to do it by mouth. Peg tube or mouth. Just give them water. But it may be that you have to give them intravenous fluids, and to do that you want to use hypotonic solutions. In this case of severe hypernatremia, you want to give them D5W. Half normal saline will work, but I want you to remember D5. In the moderate case, chances are they're just dehydrated as well as having a free water deficit. So in that case, all they need is saline, intravenous fluid resuscitation with normal saline. Hyponatremia. The treatment for hyponatremia is going to be dependent on the underlying etiology. As we'll discuss later, it may be diuresis, it may be volume, it may be water restriction. It's going to be dependent on the diagnosis, but I'm going to give you an overview using this chart. If you have hyponatremia, regardless of the diagnosis, if it is severe, coma or seizures, you're going to use hypertonic saline. That is 3% sodium chloride. You have to rapidly correct the sodium, and it is okay to do so to get them out of the danger zone. For moderate hyponatremia that has some symptoms, you can start off with intravenous fluids, normal saline. But for that asymptomatic hyponatremia, you really need to figure out what the diagnosis is in order to treat it. It's going to be disease specific. You don't just give someone some oral salt and call it a day. So then, how do you figure out what the diagnosis is? I'll say it again, hypernatremia is just dehydration. Water deficit, give them water, they get better. Hyponatremia requires more workup. So if someone comes in with a decreased sodium, the first thing you're going to do is both calculate and measure the serum osmoles. And this equation is worth memorizing. The equation that usually makes up the serum osmoles is 2 times the sodium plus the glucose divided by 18 plus the BUN divided by 2.8. And normal is about 280. And you can remember this by saying 2 times the sodium, glucose by 18. Then the 2 from sodium and the 8 from glucose make the 2.8 from BUN. 2 times the sodium, glucose by 18, BUN by 2.8. Normal is about 280. But you are going to measure the serum osmoles because this equation can get tripped up by a couple of things. So let's talk about what happens when you think there's hyponatremia. You think they're hypotonic, but they're not. In one instance, you check the serum osmoles and they're normal. This is considered isotonic hyponatremia. This is also referred to as pseudo-hyponatremia. It's caused by a laboratory abnormality and the way they've processed it. This usually doesn't happen anymore with newer machines, but it's a problem of fats and proteins. Let's call it there. Nothing else you need to know about it. If the serum osmoles are normal, no disorder. If instead the serum osmoles are elevated, now you have hypertonic hyponatremia. This is caused by something in this equation or something else. That is to say, this equation accounts for the things that are supposed to be in the body, but there are other osmotically active compounds that you can ingest, like sugar alcohols. If the BUN or the glucose is elevated, the sodium may decrease in order to keep this equation normal. Where you're going to see this happen a lot is in diabetics. For every 100 blood glucose above the first 100, you need to correct the sodium by 1.6. To use this as an example, if someone has a blood glucose of 500, that is 4 100s above 100. So you would correct the sodium by 4 times 1.6, which is about 6.5. Which means that if on the same chemistry that showed 500, the sodium was 130, you would correct that sodium by 6.5, and their actual sodium would be 136.5. Happens all the time in diabetics. And if you have this condition, you simply remove the osmotic compound. The BUN is elevated, you can dialyze them. The glucose is elevated, give them insulin. Or you just wait for the alcohol to go away. If, on the other hand, the serum osmoles are low, You have confirmed, indeed, this is hypotonic. A true hypotonic hyponatremia. At this point, you're not done, because now you need to use the history and physical exam to decide, are they volume up, down, or euvolemic? If they're overloaded, that is, their volume up, you will correct the sodium by giving diuresis. If they are volume down, you will correct the hyponatremia by giving them intravenous fluids, volume resuscitation. And if they are euvolemic, you have another challenge. On the test, it is going to be very clear whether the person is volume up, down, or euvolemic. They're going to show you the signs and symptoms of volume overload. They will have fluid from their toes to their nipples, JVD, crackles, a history of CHF or end-stage renal disease. You know that that person is volume up. On the test, they will tell you the person is volume down. Sunken eyes, skin tenting, dry mucous membranes with a history of fever or burns, some reason to lose volume. That person needs volume resuscitation. In real life, it is very hard to tell the difference between euvolemia and volume down. Unless the person very clearly has something in their history that causes them to lose free water, sepsis and burns are big ones, you cannot rely on the physical exam. You can for the test, but real life trips you up. So on the test, it'll either be obviously volume up, obviously volume down, or euvolemic. Let's go with that. If you have euvolemia, you're going to use the mnemonic RATS, which stands for renal tubular acidosis, Addison's disease, thyroid disease, and syndrome of inappropriate ADH. You work up RTA with the urinalysis and urine lights, Addison's disease with cortisol, thyroid disease with the TSH, and SIADH is a diagnosis of exclusion. In the setting of SIADH, you are going to use volume restriction, gentle diuresis, and if all else fails, you can use dimeclocycline. We talk a lot about SIADH in the posterior pituitary lecture where we explain this a little bit more. You are going to encounter on the wards that when you get to this point, you should be looking at the urine sodium and the urine osms. That discussion is very complex. Urine sodium is a surrogate for aldosterone. Urine osms is a surrogate for ADH. We talk more about that in the posterior pituitary lecture as well. I'm not going to drive it home here. For you, you will generally not be asked to interpret those lab values. Instead, do this. Okay, we talked about disorders of water, the pathophysiology, how you're going to manage it, and then how you work up hyponatremia, which makes it much more complicated. I'm going to close by talking about two very specific things, low yield, but they may show up. If ever Vaptan is a choice, it's wrong. It is absolutely contraindicated in hypovolemic hyponatremia and has no real indication. Don't pick Vaptans, they're distractors. The second thing is osmotic demyelination syndrome, formerly known as central pontine myelinolysis. If you correct the sodium too quickly, and they didn't need to be corrected quickly, you cause a demyelination syndrome that leaves the person a spastic quadriplegic. You should only correct the sodium by about 0.25 per hour. And you only need a correction of about 4 to 6 in the first day to alleviate symptoms. The exception to that is in severe. You give them hypertonic saline until they stop seizing. But in general, you want to correct the sodium very slowly, and you don't need a big change to get them out of the symptomatic range. That's sodium.